Hi there, I'm Jen Wells. I want to introduce you to the Crossvale and Scale-Out IoT solution. Data equals intelligence. Traditional business intelligence can't gather and analyze important service-oriented data in the moment. It could take hours or even days, and that's too late. ServiceMax customers have the data they need. It just needs to be analyzed immediately. Crossvale's IoT solution, powered by Scale-Out software, gives ServiceMax customers the capability to act when it matters most, right now, before the moment is lost. This isn't just business intelligence, it's operational intelligence. Scale-Out is a software platform that allows for in-memory computing on live, fast-changing data. Scale-Out stores, updates, and continuously analyzes real-time and historical data to give immediate feedback. This wind turbine demo is merely one example of how Crossvale's IoT solution, powered by Scale-Out's operational intelligence engine, will allow ServiceMax customers in any industry to take incoming, ever-updating data streams, enrich them with historical information, analyze them in parallel, and receive relevant, service-oriented feedback exactly when needed. Operational intelligence utilizes 5 phases in the path to a real-time recommendation. In the data acquisition phase, multiple sensors translate a physical state such as heat or vibration into a measurement. Wind turbines, MRI machines, scanner printers, and other pieces of machinery already have these sensors built in to perform the task. In the data processing phase, the IoT solution must process the measurement into an indication of system health. In the detection phase, this system's health is now classified as either normal, where all is good, or abnormal, where a fault may be present. In the diagnosis phase, the fault must be validated. In some cases, the fault may be validated as statistically false, meaning that based on multiple indicators and historical data, the chances are that the component is sensing false data. In the final recommendation phase, an alert is sent out via the ServiceMax service management software platform so that a human decision can be made quickly based on the perishable data presented in the moment. The Crossvale IoT solution will be seamlessly integrated with the existing ServiceMax service management software and will ensure that expensive, mission-critical equipment is properly and proactively maintained. Via operational intelligence, critical issues that can affect equipment performance and reliability will be alerted in real time with instant service recommendations. Crossvale's IoT solution is flexible and scalable. As the ServiceMax customers' real-time alert requirements change or grow, the Scale-Out operational intelligence engine will be quickly updated to adapt to the new requirements. The Crossvale IoT solution will analyze and compare the relationships of key sensor inputs and their historical service data to isolate false positive alerts from those that are truly critical. As an example, in a wind turbine environment, a high system vibration alert, typically the result of a faulty bearing, could be designated as a false positive due to already existing high wind conditions. Any machine, anytime, anywhere. The Crossvale IoT solution, based on reusable IoT frameworks, is quickly customizable for ServiceMax customers in any industry and can be easily adapted for any customer-specific use case. Let's now move on to a demonstration of what we're talking about. So here we are into the demo piece of the IoT solution. It's broken up into various components or panes within the browser. Let's do a quick overview of what we have at this point. In the top right-hand corner, we have a map that is laying out the location of our wind turbines. In this case, it shows them on our farm. We will look at that and provide some filtering a little bit later. On the left-hand corner, this is where we're looking at the power output associated with each of the turbines. Again, we will be able to provide some filtering capabilities based on these bar charts. As we come into the center of the screen, this is where we have 3 different types of alerts: actionable alerts, statistically false alerts, and perishable insights. Actionable alerts are alerts that need to be taken care of and will require one of our field operators to go out and perform some sort of maintenance on the wind turbine. We have different priority levels: critical, medium, and low actionable alerts. We will play with these just a bit later on. The second type of alert is the statistically false alert. The software has been smart enough to learn about the behavior of the wind turbines over time. Based on this historical information, we are able to determine if the alerts that are firing are real and need of assistance, or if they're firing in error. We will be able to perform a manual insight of the data that caused the alert to fire, and if a problem is located, we can then change that to an actionable alert. The third type of alert that we are offering is a perishable insight. Perishable insights give us information where we can perform some predictive maintenance on the turbines, and in that way, we can get in front of any problems that may occur down the road. Under the map, we have the geolocation information associated with each of our staff. This can help us answer many questions, such as, where are our staff currently located? Are they moving? Are they stopped? Are they already on site? And in this case, we have added some additional information with regard to the behavior of our staff. So in this example, you can see that John has been exceeding the 40-mile-per-hour speed limit. We are able to fire out alerts not only for location, but also based on their previous histories. As we come down into the bottom part of the application, we can see some of the alerts, the filters that have been applied to some of the team members, and other types of information. Again, we will come back to this in just a little bit. Let's go back up to the top and take a look at the map. This is a standard reactive Google map which can zoom in and zoom out. Another thing we can do is we can filter the rest of the information based on the context gained from the map. For example, if we click on this particular wind turbine, we can see at this point the bar chart has just changed to show the information associated with that particular wind turbine only. Again, we can do the same thing with any one that we want and turn that filter on or off as we see fit. We'll then jump over to the left-hand side and start taking a look at the real-time power production. We can then also provide a filtering capability based on this horizontal bar chart. So, if we click on the example of Texas Collin County 01, we click on that specific wind turbine and we can go down to the bottom and see all of the alerts associated with just that specific wind turbine. Again, if we click on one of the other bars, we can see the contextual information down at the bottom is based on just that specific turbine. So this is primarily about ease of use and allowing the operators of this particular solution to be able to quickly identify the information they are looking for. The central frame within the application renders the different types of alerts. As I said before, we have actionable alerts, statistically false alerts, and perishable insights. Let's play with this a little bit. Over here on actionable alerts, we can see that we have critical priority alerts, medium priority alerts, and low priority alerts. In this case, we have clicked on the low priority alerts. We can clearly see that there are 3 different turbines with a low-level critical alert. In this case, they are all due to high heat levels. If needed, we can also do the same selection to view both our medium-level alerts and high-level alerts. Let's take a look at one of our turbines down in Houston as an example. After clicking on it, we can then inspect the detail. In this particular case, the temperature associated with this turbine is above the critical level of 120 degrees. We have had multiple instances where that particular sensor has sent out a high temperature, and as a result, that is something that a field engineer would need to go and investigate. Let's look instead at the critical type actionable alerts. In this case, we have a problem with power. We can see that although the turbine is spinning, the amount of power we are producing is very low. We can also see that Reagan seems to be the closest team member that could go and take a look at this particular turbine in order to see if there is an issue with the alternator. Now, let's jump into the statistically false alerts. This is where the intelligence based on previous information comes from. We again have critical, medium, and low priority alerts. So let's take a look at this particular statistically false alert. we can see that the turbine is vibrating too much. Based on the information we are receiving, we can speculate that there is not really anything wrong with the turbine. Let me explain. We can see that the wind is varying from 64 miles per hour to negative 21 miles per hour. Then it goes back up to 54 miles per hour and back down to 6 miles per hour. What that means is the turbine is in a turbulent area and the wind is buffeting the turbine around, which is causing the false alert to come from the vibration sensor. In the Crossvale solution, we are able to take information from multiple real-time sensors, layer that over historical service requests, and calculate with high confidence when a single sensor fires a false alert. The last thing we'd like to show you today is what we call perishable insights. First off, what is a perishable asset? A perishable asset is something that wears out. Very often, this is something that moves. Examples might be bearings, tires, brake pads, or electrical motors. In this specific case, let's look at the low priority alerts. If we look at California number 16, we can see a main brake and possibly a main bearing that we need to take a look at within the exact same turbine. Let's take a closer look. We can see that this is a low priority, a perishable insight, but the turbine is working correctly. We can also see that Jose is our closest engineer to that specific turbine based on his geolocation. As I said, we can see that this specific turbine has two problems or two issues that we might want to get ahead of, both of which are reflected on the table on the left-hand side. Based on the historical data, it looks like the bearing has done 1.5 million rotations at an average speed of 7.2 RPM. Where did this calculation come from? Well, we can see both the rotations and average speed on the reports that we've compiled over time. Why should we actually be taking a look at overhauling the main bearing? If we take a look at the pop-up, we can see that it should be overhauled after 2 million rotations or after 10 years of use to lower the risk of catastrophic failure. As a result of that, while it is not critical right now, we should probably get ahead of it within the next few months. We want to reiterate that this is just a simple example of Crossvale's IoT solutions. It is quickly customizable for ServiceMax customers in any industry and can be easily adapted for any customer, any machine, anytime, anywhere. Thank you so much for taking your time and watching with us.